Any questions that pop into your head throughout the presentation, please pop them straight in the chat and we will get to those at the end. So just before we start, I'd like to acknowledge that I'm coming to you from Taungurung country tonight, pay my respects to their elders past and present, and extend those respects to all of the traditional owners of the lands on which we work across central Victoria and any traditional owners in the audience tonight. I'd also like to acknowledge all of our donors and supporters at Biolinks Alliance. We couldn't do what we do without you, so thank you for your support. On to tonight's presenter. So we're lucky enough to be joined by Associate Professor Jim Radford from the Department of Ecological, Plant and Animal Sciences at La Trobe University. Jim's a landscape ecologist, ornithologist, and a local in central Victoria. He's a fellow of BirdLife Australia, a member of the North Central CMA's science panel, amongst many other very impressive roles. So I'm going to hand over to Jim now to take it away.
Thanks very much, Chris. And thanks, Chris and Sophie, for inviting me to talk to you all tonight. And thank you for joining and your time. I'll share my screen now. And if somebody, Chris, when it comes on, just let me know that you're seeing it okay.
Got it.
Okay, great. Oh, and you're up there. Okay. So likewise, I just to acknowledge that I'm coming to you from Dja country and pay my respects to elders past and present and acknowledge their custodianship of the land over millennia. Oh, I'll just turn off my phone. Suspected spam, 6 o'clock dinner time, of course. I'd also acknowledge that this is the 4th anniversary to the day of the Mighty Demons breakthrough premiership. But anyway, we'll move on from that. So what I'll be talking to you about tonight, although up there it has natural capital and woodland birds as the title, really what I'll be talking to you about is hope and positivity. So there's no need to remind this audience, I suspect, because we're reminded every day that we're in the midst of the dual biodiversity and climate crises. And, you know, we're reminded about this all the time and for good reason. They're very real, they're very now. The world is in trouble because nature is in trouble. And we, humans, collectively are responsible for that, largely. And so I think it's upon us, humans, that we need to change to reverse these crises, at least to manage them. And I know that thinking about the natural world can at times be daunting and overwhelming. And it's easy to suffer from overload or fatigue that's caused by biodiversity distress. It can often seem hopeless and we often can feel helpless. But that's the downside. I hope that after this presentation, you'll have some hope, that you have reason to think and believe that we can make the world a better place. I hope that I'm able to offer you some reasons for positivity in the next 40 minutes or so, and how landscape ecology, particularly, it's my sort of discipline and area, can be harnessed to make the world a better place with the support of people like yourselves that are interested and have a passion and a will to change. So before getting into it, I'd just like to acknowledge that I'll be presenting work from a whole bunch of different projects that I've been involved in over the last 20 years or so, and that these people on this screen here have been central to at least one, if not more, of those projects, and just acknowledge their contribution as colleagues, friends, legends, and champions of this work. So I suppose I leant into it a little bit at the start there, but I'm going to set the context for this work, and a lot of it is bad news. So as I said, as you all know, we are in a biodiversity crisis. Rates of species extinction are somewhere between 100 to 1,000 times the background rate, that is the non-anthropogenically caused rate of species extinction. You often hear denialists saying things like, oh, species were always going extinct, there's nothing new, and they were. But they were going extinct at a background rate of about 0.1 to 2 extinctions per million species per year. And what this graph shows is that we are exceeding that, depending on the taxonomic group that you look at, between 1,000 up to 1,000 times greater than that background rate. So we are losing species at an unprecedented rate. We are in the 6th mass extinction, whether we like it or not. As well as species going extinct, we're also in the midst of what has been termed, and I think it's a great term, unfortunately, called the great thinning of wildlife. So if you go for a walk in your local patch of bush, your forest, you might see most of the species that you expect to see there, but their numbers, their abundance will be much lower than what they once might have been, or that you might remember them being, because they might well have been, 10, 20, 30 years ago. Across the world, not only are we having species extinction, we're having this thinning, this reduction in the abundance of species right across the landscapes. We're experiencing ecosystem collapse. This is very sobering. This map's from a very sobering paper from a couple of years ago that looked at ecosystem collapse in 18 of about 20, key ecosystems in Australia. And we know that the numbers of threatened species continue to climb, whilst all of the indices that we look at that track the abundance of populations and of threatened species continue to plummet. So this is the latest, just make sure I get the latest Living Planet Index that WWF releases. It goes from up until 2020. It was released in 2024. It is the most recent one. And basically what it does is it benchmarks populations of species that have long-term monitoring data back to their 1970 level. And this is for the Asia and Pacific region that Australia is a part of. And this index represents 4,500 populations of over 750 individual species. And it suggests that we have about 40% of the abundance of that biomass across those species now as existed in 1970. So we've lost 60% in my lifetime. The global index is even worse than this. So our region is doing a little bit better than globally. And birds are right in the thick of this decline, of this thinning, of this extinction crisis. So this is the Australian Threatened Species Index for birds, for terrestrial birds only. And so this index, similarly, same principle, but it's pegged to 2000, that's the benchmark, and it shows a 60% decline between 2000 and 2021 across 44 species of threatened terrestrial birds in Australia. There's over 12,000 individual time series that go into this index, with an average time series length of 10 years. So it's not some made up hokey pokey data. It's real data. It's an extensive data set, and it's showing a very bad and sobering story of extensive decline of our threatened species, threatened bird species, threatened terrestrial bird species. And we know that woodland birds are a significant part of this index. So this is all terrestrial species. So it does include other groups of birds, but woodland birds form a significant part of this index. And of course, one of the reasons for this is quite simply that farmers and woodland birds like the same habitat. There is this co-occurrence of agriculture and woodland bird habitat. So this map here shows the major agricultural land uses in Australia very broadly, with grazing on native pastures, very extensive in the rangelands, the tropical savannas, semi-arid shrublands in WA over here, and sort of western New South Wales, southeastern, sort of eastern South Australia, and semi-arid grasslands. And then we can see these intensive cropping. This is the dark blue, the dark green, I beg your pardon. The intensive cropping and grazing on highly modified pastures through this, what's known as the sheep wheat belt, that's outlined in the dark black here in the eastern seaboard, inland of the Great Dividing Range, and in southwestern WA. So this is, colloquially known as the wheat and sheep belt that you're all familiar with. This is, of course, also where the grassy woodlands and these grassy ecosystems occur. And this map on the right shows the current extent in green and the previous extent that's been cleared since European colonisation in 1750 of these eucalypt woodlands, these grassy ecosystems, and showing extensive clearance through that same zone, that intensive agricultural zone in inland of the Great Dividing Range in eastern Australia, into Tassie here, the Midlands of Tassie, and in southwest WA. So what remains in large parts are only small isolated fragments, often along creeks, along roadsides, and potentially rocky outcrops as well. And so this is the same map here, just transposed to the next slide. But this is, of course, the same grassy woodland habitat that our beloved woodland birds also inhabit. So this map on the right shows the rough distribution of several of the sub-communities of woodland birds that make up, that greater, assemblage, association, what we might know as woodland birds. And so this co-occurrence with the most cleared parts of Australia is quite striking. So you might think, oh, well, that's all good. We've got national parks and conservation reserves. That's enough to look after them. Well, it's not. This is a map here of our national reserve system. And thankfully, under the Global Biodiversity Framework, Australia has committed and is obliged to increasing this to 30% of land to be protected in the National Reserve System by 2030. But this is, as it was a couple of years ago, the most recent CAPAD database. And what we can see is that through these zones we were just talking about, the sheep wheat belt, there's lots of little tiny reserves scattered through here, either in public and private land within the Conservation Reserve System. But overall, most of our protected area is outside of these grassy ecosystems, these grassy woodlands and grasslands, in the arid zone, tropical zone, wetter zones on the Alps, and along the coastal region. And so this is not only underrepresented or underprotected in terms of the absolute area that's in the reserve system, but if we're to look at other measures of how well protected they are, such as representativeness of the different ecosystems in the reserve system, or adequacy of those ecosystems in the reserve system, we perform poorly in these areas as well, within these agricultural zones. So we have these extensively cleared, highly modified, poorly protected and underrepresented ecosystems in the National Reserve System. And they support much of our unique and archetypically Australian flora and fauna. So this means the extent to which biodiversity and woodland birds as our protagonists and species group in focus in this talk in particular, the extent to which those species can coexist with agriculture will have a large bearing on conservation outcomes for woodland birds in Australia. But this is not just an Australian issue. This is a global issue as well. So some of these photos are typically Australian, that you'll recognise, but others are from other parts of the world where these issues are just as live and just as urgent and just as timely as we're facing them. So, for example, here in southeastern Australia, we have 51 species or subspecies of woodland birds that are threatened or in significant decline and occur mostly on farmlands. These 45 of them. And as well as these 50 or so species and subspecies, we have hundreds more that are not yet considered threatened, but as part of that great thinning, are less abundant than they used to be. So we have this dual challenge of protecting and recovering threatened species, but also keeping what's common. So to restore ecosystems and to reverse this biodiversity loss, we need new ways to value, to measure, and to manage biodiversity in agricultural landscapes. The reserve system is critical. It's important. It's the backbone of our conservation system, but on its own, it won't be enough. We need to manage biodiversity in agricultural landscapes, which represent 55 to 60% of the Australian land mass. So I'm not laying the blame here at the feet of farmers, because a lot of this is historical. It's a legacy of past land use practices, and many government policies, through the ages, forced people to clear land to have these land uses. And at the moment, Australian farmers are, like their counterparts around the world, are facing increasing pressure from international markets and their various supply chains to improve their environmental performance and to demonstrate their sustainability credentials. Yet at the same time, we want lower prices at the supermarket. Cost of living is going through the roof, and a lot of that is food costs and people, wanting lower costs at the supermarket. And we're needing to feed and clothe, a larger global population. So we're asking farmers to grow more, to grow it more productively, to grow it cheaper, and to do it with less environmental impact. That is a big ask. And so this is the context. This is the wicked problem. The birds that we love, these woodland birds on this slide, prefer the most productive and fertile parts of Australia, which have been extensively cleared and modified. They're poorly represented in the conservation reserve system, and these same areas are needed to grow the food and fibre to feed and clothe 6 billion or 8 billion people, and to do it sustainably and to do it cheaply. And increasingly, these same areas now are being asked to generate the renewable energy through wind and solar farms as well. So it's no wonder that we have, a bit of a paralysis by what the hell can we do here? So this is the conundrum. How do we turn this ship around? Can we have production agriculture that supports biodiversity, that is productive enough to feed and clothe the world? So I hope to convince you that we have some answers. And this is where I start to swing it around and become much more positive and try and provide some solutions. And the key, I would claim, to this is on-farm natural capital, which is not new. It's not new. But what is new is generating new reporting requirements, sharing the burden for restoring and maintaining natural capital in agricultural landscapes, generating new markets to support and reward farmers for managing their natural capital sustainably. So a few definitional things. When I talk about natural capital, it's very broad-based. It's all living and non-living natural resources that combine to provide products and services that are of benefit to people. So in an agricultural context, it includes everything that you see in this slide here. It includes the soil and water resources. It includes native vegetation and native fauna from the invertebrates and in fact, the soil microbes, soil microinvertebrates, macroinvertebrates, through to the birds and the bees and reptiles and mammals and all of the native fauna in agricultural landscapes. It also includes modified ecosystems such as pastures and crops. So it includes both the naturally occurring ecosystems, grassy woodlands, forests, grasslands, shrublands, in their close to reference state, but also in all of their various disturbed states, through to ecosystems that have been established and are maintained by humans that probably comprise mostly of non-native species such as shelter belts and often shelter belts, but so crops and pastures and the like. I'm not going to dwell on it, but I am going to talk a little bit about natural capital accounting, because that is one of the mechanisms through which we can value and put natural capital on books. So this is a view of a farm through the lens of a traditional financial accounting system. This is the only things that are of value to a farm that are recognised in traditional financial accounting. So things that go through the farm business account, so the income and expenses, some of the infrastructure assets, obviously the livestock themselves, the crop that's taken off, the machinery and the plant and equipment, and there's property value that's associated with it. But all of these elements are missing. The ecological assets, the natural capital, are invisible in financial accounting, yet they underpin the whole production system. And this demonstrates, this graphic demonstrates that the natural capital assets generate a whole range of services that are of economic benefit. Some of those are direct offtake. They're direct products that are used by the farmer, taken to market, and they get a financial return for them. But very often they're in the form of what we might call regulatory or intermediate ecosystem services. That is, services that underpin the production of those agricultural products, the provisioning services. So you can see some examples here, such as the shelter belts or remnant vegetation that provide shelter for livestock or provide habitat for beneficial insects. Natural enemies of pest species or pollinators or waste decomposition. Obviously, we've got the soil that underpins soil fertility, the composting functions that occur in the soil, and nutrient cycling, and the water, both in the subsurface but also on the surface that feeds the crops and pastures that grow most of what we eat and produces the fibre. So there's a lot of benefits that are of private good, and they're represented here in the sort of brown through services that avoid expenses for the farmer or services that contribute to the production of resources. But there's also a whole bunch of services that benefit society through the provision of habitat for wildlife, through sequestering carbon, and when managed well, through protecting waterways. So riparian vegetation and doing biofiltration and things like that. So natural capital accounting, or environmental economic accounting, has often been promoted as a tool for quantifying and valuing these natural assets on a farm, or for quantifying and valuing these natural assets and reporting on environmental performance. But it's rarely been done at the farm scale. That's where our projects kicked in. There's a whole framework, the UN National System of Environmental Economic Accounting, Ecosystem Assessment, that defines how to do this, how to measure the various assets and the services that they provide. And I'm not going to bore you with. Suffice to say that we've adapted many of these principles to measure natural capital at a farm scale, and that's where our advance was, and have developed a whole bunch of metrics derived from those accounts to quantify natural capital at a farm scale. And what I'll show you now is how they relate to biodiversity. So 5 reasons for hope. This summarises what I'm talking about for the rest of the talk, really. Natural capital benefits woodland birds on farms. Natural capital also benefits agricultural production. So we've got an amalgamation of benefits there. We know how to do most of what we need to do. We know that restoration of native vegetation on farms works to bring birds back to landscapes. We know how to improve the ecology of the environment of most farms. And increasingly, there are drivers of change on the horizon that can catalyse and stimulate and trigger and support this type of work. Okay, so natural capital benefits woodland birds on farms. So just quickly, this was the natural capital accounting project that I led. These champions in the right corner undertook most of the field work. We developed farm-scale natural capital accounts for 50 farms. You can see their distribution here from the New England tablelands right through to the slopes of southwest, the inland slopes of New South Wales, north central Victoria, and the Tassie Midlands. 50 farms in all, grazing, mixed farming, and cropping enterprises from 330 hectares right up to large farms, 16,500 hectares. We did a whole program on compilating the accounts. I'll talk about very briefly. We had what we called a natural values program that looked at the relationship between natural capital and the birds and the bees, the birds and plants and invertebrates. And that enabled us to develop predictive models of, I'll show you the bird richness, which can be used to generate biodiversity asset accounts. Putting natural capital on the books. So don't be afraid by this. This is what underpinned our assessment of natural capital on farms. It's a state and transition model, in this case for a grassy woodland. And it represents all of the different ecosystem types that would have formerly been in a grassy woodland that we might find on a farm. So it allows us to assign an ecological type and condition to the natural capital assets that are on a farm. So ranging from remnant vegetation that's in a relatively or very high, almost reference condition state, through to that, what we call transitioning woodlands that were still recognizable as woodland ecosystems, but in increasing states of modification, to derived grasslands that might have had their canopy layer removed to improve, to allow for more pastures for grazing, but still retained a lot of native elements in these higher states, through to ones that were entirely exotic, through to cropping systems, and then areas where we were putting trees back into landscapes, so replanting for shelter belts or woodlots or biodiverse plantings, and then a whole bunch of stuff in the middle that represents other things that we find on a farm, such as native shrubs or horticulture or exotic woody vegetation or shrublands that are coming back, different things. The point being, we can allocate each hectare on a farm to one of these boxes. We can add it all up using remote sensing and field-based assessments, then use various imputations to generate an asset register. What have you got on your farm? Roll that all up to generate a natural capital account that represents how much natural capital of different types of assets you have on your farm, what's your extent of them in area terms, in hectare terms, and in what condition they are in. And then from that, we can use various modelings to represent the other ecosystem services that those assets provide, such as carbon sequestration, or shade and shelter for livestock, or we looked at the invertebrates and looked at the provision of habitat for pollinators or beneficial pests or waste decomposers and those sorts of things. We looked at ground cover and soil condition, and various ecosystem services that the natural capital assets can provide the farmer. Those things that were of production benefit in that earlier graphic. But I'm not going to talk any further about those. So we also went out and we did a whole bunch of sampling. We had a whole bunch of bird surveys, over 1,000 sites for birds, between 9 to 35 sites per farm. We sampled them representatively depending on their ecosystem types, those natural capital asset types that I was just talking about, surveyed them representatively, 4 times each, basic standard surveys with our eyes, not with acoustic recorders, eyes and ears. And we generated some big numbers. So we did over 4,500 bird surveys as part of this project, which recorded 227 species across these 50 farms. That's a quarter of all of Australia's bird species on farms. These are all farms, no conservation reserves, nothing. It's all private land. That's if we include around 27% of Australia's bird species, including Western Australia and Northern Territory and seabirds and everything. If we think about only those species that are likely to occur within the bioregions that we surveyed, there's about 71% of the species that we recorded on those farms, including 34 species that were listed as threatened at national or state level, and 9 that were EPBC listed, which are the 9 that you can see here. So this is, to me, this 71% of the birds in the study region was a profound stat. These 50 farms would represent way less than 1% of that total study region, yet we're getting at least one, record of, over 2/3 of all of the birds that occur in this study in this region, which shows, I think, that the importance of farmlands for supporting these types of birds in southeastern Australia. So if there's nothing else, that's a take home from this talk. This was the relationship between the number of woodland birds that we saw within a hectare and those various natural capital asset states that I was talking about, from a reference woodland through to more modified or more disturbed woodland types, and in various grasslands and things like that. And the point being, not surprisingly, is that the better the condition of the woodland, the more bird species more woodland bird species. This is woodland birds only we detected, and in where there was no canopy, not surprisingly, we saw very few. Scattered trees improved things a little bit. The planted trees, yep, we can see quite a few species of woodland birds in some of this replanted area, and even some of the exotic woodland habitats support quite a few woodland bird species as well. So the better the condition state, the more birds and scattered trees make a difference. But the key point about this is that we can map this. This allowed us to make maps of woodland bird species richness across farms. So this is one of those. This is the modelled or predicted diversity richness of all birds in this map that's up here at 1 hectare as a function of the ecosystem type on a farm, determined by the condition state, but other factors as well, such as topographic features and the patch size and some few other factors. But it was ecosystem state that determined was the most important factor. So this is for all birds. We can do it for woodland birds, and in this farm, it's not a very good farm for woodland birds because the white areas are suggesting that there's no woodland birds. We're only looking for the darker the blue, the more the predicted woodland bird species richness. And so we can see on this particular farm, there was only 155 hectares that we would have called very good habitat for woodland birds, and another 136 hectares down here mostly that would have been good, and there was none that was outstanding, so the vast majority of it was poor or moderate. Other farms obviously performed a lot better for woodland birds than this one. And we can do it for other bird groups as well. We did it for grassland birds, Like the scale here for species richness is much different because there's many fewer grassland birds, but a lot of that farm is quite good. Not surprisingly, it's mostly cropping. So this enables us to convert predicted species richness to an aerial measure of the condition of the habitat, the condition of the farm for woodland birds. And we're able to do this for plants as well. And so this, again, enables us to put the biodiversity on the books. We also developed a whole bunch of different indices from remote sense data and field validated assessments that enabled us to compare natural capital to the financial performance of the farm. Oh, sorry, skipping ahead of myself. That enabled us to characterize the natural capital at the whole farm scale. So what we were looking at before was just at a site scale. When we look at it at a farm scale, we see again this positive relationship between various measures of natural capital, the condition of it overall, how much woody vegetation cover, how aggregated is it, how clumped is it into larger patches. The proximity is how close are production areas to woody vegetation. And most of these have a strong positive relationship with the species richness of woodland birds at the farm scale. So again, this positive relationship between natural capital on a farm and woodland dependent bird species, and mostly for all bird species as well over here. This is for plants. We see these relationships being largely repeated over here as well. So perhaps it's no surprise, but well-managed farms with good quality remnant vegetation can support many species in a range of woodland bird species. And indeed, many woodland birds in turn depend on farms for their survival. But what I'll show now is that this doesn't have to come at a price for the farmer. So through the Farming for the Future project, we looked at the relationship between these same natural capital indices and measures of farm economic performance. This was done on a larger set of 130 livestock farms. And these champions over here did the crunching on the financial data, the statistical analysis. This is the basic premise of Farming for the Future. This is a measure of the natural capital on the farm on the x-axis. This is some measure of farming environmental performance on the y-axis. Here it might be profits, profitability, production, efficiency, something like that. And the expectation is that that will improve with natural capital up to a point. There'll be a private benefit for the farmer, plus also a biodiversity outcome up to a point, after which the economic value for the farmer will start to decline. There'll be a trade-off, opportunity costs and such, whilst the natural capital index continues to increase. And we also predicted that the stability of income the variability, the volatility in income would decline with increasing natural capital. And this is largely what we found. So natural capital benefits agricultural production as well. Over here is a measure of, on the left is a measure of proximity. So this is a measure of the distribution of woody vegetation across the farm. And if there's more woody vegetation distributed across the farm, the gross margin, this is only livestock farms, by the way, the gross margin increases. This is the whole farm earnings before income and tax, so a measure of gross income. And we see this is related to ground cover. Not surprisingly, we see a positive relationship, but this evidence of this flattening out at this plateau. And this is resilience. This is the stability of income over time in the face of climate volatility or market shocks. And this increased with overall ecological condition on the farm. So we're seeing this coalescence of improved natural capital, different elements of natural capital, leading to improved productivity, leading to improved profitability, and leading to improved stability of income, or what we call resilience in the face of climate and market variability. So we're getting natural capital not just being great for woodland birds, but it's also very good for farmers when measured at this whole farm scale. Now, the rider on that is this was livestock farms, and we want to expand this data set to look at other farming sectors and more broadly across the country as well. Very quickly, the third reason for hope is that we know that restoration of native vegetation on farms brings birds back. So we know we can improve ecological condition, doesn't make a difference at landscape scale. This is work that was supported by Glenelg Hopkins CMA and led by Andrew Bennett and Angie Haslam that looked at 43 landscapes that were each about 8 kilometres squared in size. You can see them here down in the Glenelg Hopkins catchment. And they varied in whether those landscapes were composed of remnant vegetation only, revegetation only, so the landscape's been basically completely cleared and then replanted, or a mix of remnant and re-veg. And there was a gradient from very little native vegetation, less than 1%, through to about 20% remnant native vegetation. We surveyed these in 2009. And this is what we found. The species richness, so this is woodland birds only, increases with the amount of native vegetation in the landscape. We already knew that, so that wasn't a new result. We expected that. But what we see here in these green lines, these are the revegetation landscapes. So if a landscape is almost completely cleared, back down to zero, and then is replanted back out, birds come back. We get species richness of woodland birds climbing back up to around about 25, 26 species per landscape. These are only quite small landscapes, by the way. And it can almost get back up to the level of these remnant vegetation as if it had never been cleared before. And these light brown landscapes here are the mixed landscapes. So if you've already got some remnant vegetation remaining, but it's been reduced, but then you supplement it with plantings, you can get it back up to a level that is equal to that of a completely remnant vegetation landscape. There's no difference in the species richness compared with the remnant vegetation landscapes between the mixed and the remnant. So this is great news. These findings are profound. We can return species to landscapes through replanting, through re-veg, and it can do almost as good a job as the remnant vegetation. But the types of species are different, and this is what this graph shows, these plots show. So restoration works, but it works particularly well for these mid-story insectivores like thornbills and wrens and things like that. So this is the summed reporting rate, the incidence of all of the species within those foraging guilds in the revegetation landscapes and in the mixed landscapes compared to remnant. And this is for canopy insectivores. Do okay in the re-veg, not quite as good as the mixed and the remnant. For bark and trunk foragers, tree creepers, satellas and the like, the revegetation is not mature enough. It's not old enough at this stage, so fewer species. Aerial insectivores like wood swallows and martins and things like that don't do as well in re-veg, but there's still some there. And the canopy feeders do quite well in re-veg, but there's still some difference. This was in 2009. When we resurveyed in 2019, we found very little difference. So it takes time. We resurveyed 12 years later in 2019. And this is just species richness of woodland birds per landscape in the remnant landscapes in 2007 compared to the restored or the revegetated landscapes. And there was a difference. That was the difference we were looking at. When we resurveyed in 2019, there was no difference between the re-veg and the restored and the remnant in total species richness. We still had some differences in the composition in some of those foraging guilds. For example, hollow nesting species you're not going to find in the re-veg landscapes. But, you know, this is a really positive message. We can make a difference. Revegetation on farms will provide benefits for biodiversity and will bring species back as long as there's a source population within a dispersal distance and the re-veg is of high enough quality to support different species. Nearly done. The fourth reason for hope is that we know what to do. We know how to attract and keep woodland birds on farms. This is the things that land care groups have been doing for decades now. And the good news is it's been the right thing to do. We need to maintain existing habitat. No further clearing is critical, including scattered trees and paddocks. We can improve habitat quality through supplementary planting, through grazing management, through retaining fallen timber and feral herbivore control. These are in order, priority order, by the way. We need to maintain and improve riparian habitat where we can through exclusion of stock, off-stream watering, and better management of farm dams and replanting. I didn't show it, but riparian habitats are critically important in agricultural landscapes. And then only once we get down to about priority number 4 do we do replanting and increase the extent of habitat for species through strategic re-veg. Where we can, improve the connectivity, but it's more important to get habitat back in the landscape, no matter where it is, than to increase connectivity. And then finally, feral predator management we know is important, or can help for some species as well, particularly ground-dwelling species, obviously. Don't look at this horrendogram necessarily, or the details. Again, what this shows, if we did a literature review led by Angie Haslam, that it has multiple benefits. So doing these things, maintaining remnant native vegetation, restoring landscapes through these mechanisms will improve not just biodiversity, but it will improve farm productivity, it will improve carbon stocks and therefore help mitigate climate change, it will improve soil health, it will improve local water cycles, and it will improve amenity and human well-being. There are multiple benefits to be had. I'm going to skip over that one. And the 5th reason for hope is that there are drivers for change coming. The world is changing. There is increasing pressure from consumers, from governments, from markets and farmers to be more sustainable. Some of this is coming from the farmers themselves. A lot of it is, in fact. The key one that I'll put at the top is self-interest. Through Farming for the Future and other such studies, we're showing that there are production and economic benefits of farming sustainably. We have lower input costs. We can have increased efficiency. We have climate resilience. Farming regeneratively, or not even regeneratively, just farming more sustainably is better for the bottom line of farmers. It should be a business decision. That's why they should and are changing practices. Here are some examples of brands that shout from the rooftops their investment in their supply chain through various mechanisms to improve natural capital broadly. I'm not saying they do it well necessarily, I'm saying that they are advertising it, their social license to operate. And this is coming from consumer and shareholder pressure to improve their sustainability within their supply chains. And this is gaining traction. These are just a couple. There's more companies, large corporates that know that they're under pressure to improve their sustainability footprint. And this will gain traction. Large companies in Australia now have mandatory Scope 3 emissions reporting. In time, there will be mandatory Scope 3 nature or natural capital reporting through things like the Task Force for Nature-Related Financial Disclosure, where companies have to report on their impact and dependency on nature. And so this mandatory reporting will drive a change through the supply chain and drive the producers that produce the raw materials. Hopefully they'll be able to gain premiums and support financially for doing so, for producing those goods more sustainably. The Kunming-Montreal Global Biodiversity Framework introduced Nature Positive. Governments around the world have signed up for this. They have obligations now under this, made commitments to be nature positive by 2030. So in Australia, the main policies are this 30 by 30 to increase the natural reserve system, but also the nature repair market, which is hoping to create a market for biodiversity on agricultural land, in private land, most of which is agricultural land. There is increasing market demands. The EU deforestation regulation is the most obvious of these. This market access will only be granted to the European Union market if the suppliers can demonstrate that it's not on the back of, or it's not due to deforestation. Other brands are doing this and have been doing this for a long time. And here's some here that have quite outstanding sustainability criteria that only source their raw materials from sustainable farms. The moment they pay a premium for it, I think in the future, it'll be market access, not premiums, that drive these improvements in sustainability. And finally, there's an increasing number of companies, investment companies like Wedgetail and the Tiverton Agricultural Impact Fund, that are looking to invest in sustainable ag, not just for the good of it, to make them look good, but to turn a profit. So they produce agricultural products, they offtake from the system, but they also generate income from nature credits, akin to the carbon market, and and other ways of generating income through biodiversity and nature and natural capital on farm. And financial institutions, banks and insurance companies are major players in driving change by providing better terms to farmers that are actively managing and building their natural capital. This is because it reduces their risk to things like nature risk and to climate risk. They're doing it from a business perspective, not from a feel-good perspective, doing it because it makes good business sense. This is also gaining traction. So what's not in this list is things like stewardship payments, philanthropy, price premiums, government grants, tax breaks. So some of these things can contribute, they all contribute, but I don't think they're going to be big enough and sustainable enough to make the whole scale change that we need to do. I think it's these things on this list that is going to be the major drivers of change that will improve sustainability in agricultural landscapes, improve the natural capital, which will in turn benefit woodland birds, and it will be a business decision. So I do think that time is coming. Skip over that one. So thank you very much for listening. I've gone over time, but hopefully there's a few questions, a little bit of time left for questions.
Yeah, it's great. Thanks, Jim. Super fascinating presentations. I don't think anyone minds going a little bit over. That was really good. And some little nuggets of gold, I'm sure, for a lot of our people in the audience. I've got a few questions that have trickled in. So start from Claire. What method did you use to monitor the birds throughout those studies, and what seasons the birds were surveyed in, if there was a consistent time of year?
So yeah, we surveyed twice in spring and twice in autumn across that region. We just used observational survey. Well, a cut down 20-minute 2 hectare survey. It was a 10-minute 1 hectare survey because we had some quite small areas that we wanted to buffer from the regions. So yeah, basically a revised method of the 20-minute 2 hectare survey that BirdLife commonly uses.
Great. Carl has asked for your opinion around ecological thinning.
Yep.
He has significant areas of single age, 20+ year eucalypt regrowth, really lacking in understory. So curious to hear your thoughts on that approach.
Yeah, look, I mean, I think it's a case by case example. I'm not one that's going to say that ecological thinning is not something not to be done. I do think in certain circumstances there's a case to be made for it, particularly where the regrowth has been caused by some sort of human caused disturbance, rolling or repeated coppicing for different reasons. So yeah, I think often that it's not a bad ploy now to improve structure and to release some resources for the trees that remain. So yeah, I think in the right circumstance, done correctly, ecological thinning can be a really useful tool.
Yeah, great. And I guess that's gaining traction more and more around Australia and around the world. So we're more and more data points, I suppose, coming out to help guide those decisions.
Yeah.
Louise is wondering if you provide a service to undertake natural capital assessments for individual farms and monitor them, or I guess if not, do you know if anyone's doing this?
So, Louise, I wish we could at the moment, because of the on-ground assessment part. It's not really, well, it's not financially viable for many farmers to do that. Some large farms and corporates are doing it. We don't provide a service. I'm a university researcher, not providing a service for that. We are trying to increase capacity within the farm advisor network, for example, to have better literacy and skills to generate natural capital accounts that do much of this stuff. And we are working on research projects to bring the cost of that initial estimate of the natural capital assets on a farm right down through use of AI and remote sensing and things like that, so that we can have a first cut of the map that reduces the amount of field time required to assess the natural capital on a farm. I don't think we ever want to get rid of the field time, because that conversation that the farmer has with the person who's coming out to assess the natural capital is really critical. But instead of it being 3 days or 4 days, It'd be great if that could be one day. And I think we can get there. So we don't provide a service. There's nobody that really is, there are a lot of ag tech companies out there that will provide some of the elements that I've talked about, canopy cover, carbon sequestration, different elements, but not all of it in a integrated way like that.
Yeah, great, thank you. Question from Karen, wondering how your methods, or do your methods differ to those of accounting for nature? So I guess in terms of how you're quantifying natural capital values and things like that.
Well, accounting for nature, is a certification standards organization. So there's a whole bunch of methods, I'm sure you know, and there's a whole bunch of methods that sit under the accounting for nature stamp that they've approved as a way of doing things. We're working towards a natural capital accounting method for rangelands, I think, that might be going through the process of accounting for nature yet, but they don't have a whole of farm holistic method for natural capital accounting I'm aware of. They have elements that they've got a woodland bird, or they've got a bird method, for example, that is similar but different, and they've got other methods to measure. Again, it's a bit like the question before. There's other methods that measure individual parts or bits of what goes into the farm scale account. But they don't have a holistic overall method that is a whole of farm natural capital account that I'm aware of.
Yeah. Peter has just put in that he's spent significant funds on fencing off riparian areas and planting out their farm. Obviously, it's really expensive in terms of fencing off individual trees when you get to the point of adding paddock trees and that sort of thing. Do you know of any government grants or any other approaches to support this? And if Jim doesn't, then anyone in the chat, feel free to add anything that you know as well about that.
I mean, it's a matter of keeping your eyes and ears out. There's different ones that pop up from time to time, depending on where you are. That's the problem, Peter. They're often very localized or have geographic bounds put on them. A particular CMA or might be a land care group or something that's offering them. Over time, there's getting fewer of them, I think, to be honest, in terms of just fencing and planting out. But again, depending on what area you have, how big your property is, and what you want to do, you could consider the nature repair market project. You could consider putting a proposal together. It's not. This is one of my issues with the nature repair market. I think I'm a great supporter, but it is quite complex in terms of putting the project plan together, putting it all together, but and how you need to monitor it over time. But there is the opportunity through it for significant funds if buyers come into the market. So I don't have a straight answer for you, sorry, Peter, but there are definitely grants that come around from time to time. I don't know of any right at the moment. But the nature repair market is where the Commonwealth government, at least, is sort of putting their investment, and that's what they would be advising you to do, is to put together a project for the nature repair market if you've got a substantial enough area.
Yeah, great, thanks. And Jennifer has just mentioned the Trees on Farms grants through Agriculture Victoria, which are one option. Not sure exactly around the guidelines around those, but worth a look. And as you touched on, it's always worth, I guess, keeping tabs on what your local land care group's doing, if they've got any funding or putting in for any funding that might support that sort of activity as well. Something that comes up. Carl asked, can you develop a simple method of NCA by relating it to bird species diversity and species by guilds? So correct me if I'm wrong, Carl, but basically a fairly simplified, very, I guess, usable version of what you've sort of presented that people could apply in their local area.
So reverse engineer it, sort of, by getting the bird information first. Yeah. So I've never been asked that before, Carl. That's a new question. Thank you. Cool one. I've got to think about that. I think it would be more expensive to do it that way, to be honest. But I mean, we in the bird part of our project was a research project, and we wouldn't do that, the bird surveys, as part of developing accounts for new farms. We would just hopefully take the models and apply them within that same area, that same sort of grassy woodland biome. I don't think it quite gets that to the same elements. If I understand your question correctly, if we're just looking at the bird species richness and the guilds, and then sort of reverse engineer it to say what type of natural capital we have on a farm, I think the margin for error is a little bit great in terms of then imputing or extrapolating to other ecosystem services. I think we're better off trying to assess the extent and condition of the ecosystems, the natural capital assets themselves, and then asking what are the services, the various services that they provide. One of which is biodiversity. Another might be, water cycling or carbon sequestration or storage or various things. So theoretically, you possibly could have a crack at reverse engineering it that way, but I think errors. I think will be more difficult to do, and open to quite a few errors.
Yeah, thanks. Interesting way to think about it. Anyway, all right, last one from Louise. How long will it be before a more commercial natural capital account process will be available? So yeah, good luck answering that one.
Look, it is something we're working towards. I'm not interested in commercializing this, but there are parties out there that are. I think, at a guess, probably 3 to 5 years. We've got to get the technology to make better use of remote sensing and AI to do that part of it. Maybe that's at the long end, maybe 3 years.
Great. There you go. Not too far away.
I don't know. Don't hold me to it, but I think that's not unrealistic. Minimum 3 hectares, 2,000 per. No, 2,000 K per. No, wait. Minimum 3. If somebody's charging you $2,000 per hectare, they're ripping you off. That's not what it. Yeah.
That's in relation to the Agriculture Victoria.
Oh, that's in relation there. Sorry,
Yeah.
sorry,
Yeah.
sorry, Jennifer. I missed it. I missed the context there. I thought you were talking about.
Yeah, Jennifer mentioned. Yeah, so
sorry.
yeah,
Yes.
they'll give you 2K per hectare, minimum 3 hectares per grantee.
Sorry, Jennifer. I thought that was in relation to the question.
That's one.
Not the trees on farm.
That's one worth looking into for people who have looking for support to revegetate on their farms. But we've ticked over 7 o'clock, so we'll call it there for the night. Massive thank you, Jim, for that presentation. Really appreciate you giving up your evening to talk to us. Super fascinating, and I'm sure everyone in the audience agreed. If you joined us late at all or want to share this with anyone, it'll be distributed and available online at some point in the next week or so. So yeah, thanks again, everyone, for tuning in. Thanks again to all of our donors and supporters here at Biolinks Alliance. And yeah, massive thank you to Jim.
No worries. Thank you, Chris. Thanks, everybody, for listening. Appreciate your attention, your interest.
Thanks.
Cheers.